Okay, let's look at station number 3. I've got 3 terms here. I look for a common factor. There isn't one. So now it's a trinomial where a is not 1. So I've got to multiply the a times the c and look for numbers that multiply to 24 but add to negative 11. So I've got 2 and 12, negative 2 and negative 12, 3 and 8, negative 3 and negative 8, 4 and 6, negative 4 and negative 6. Let's see what these add up to. I built my list up pretty good. That adds to 14. That adds to negative 14. That adds to 11. That adds to negative 11. Yep, that's the winner. We needed negative 11. So when a is not 1, the method is recopy the first term, recopy the last term, and split the middle term in two, the negative 3 and the negative 8. So I'm going to do the negative 3x and then the minus 8x because I think 2 and 8 factor better and 3 and 12 factor better than if I switched them. The 3 and the 2 won't factor well, right? If I did minus 8x minus 3x, this 3 and this 2 aren't going to go together nicely. So this is the way to do it. All right, so now I'm going to factor by grouping. So I common factor out a 3x out of these first two. I'm just doing these two first, right? So if I factor out a 3x, I get 4x minus 1. And now if I factor out these two, I'm going to factor out a negative 2. I always, if this is a negative, I factor out a negative. If I factor out a negative 2, I get a 4x, and then a 2 divided by negative 2 is a negative 1. Now I see that these both have that common in factor, so I common factor out a 4x minus 1. I'm left with a 3x minus 2 if I divide it out. Okay, number 2, I'm looking for a common factor. I've got 2 terms. It looks like 4 is going to be common. So if I divide by 4, I get m squared. And then 196 divided by 4 is 49. And now I can go further here. The 4 I keep track of, this is a difference of 2 squares. So I got 2 terms. I see subtraction. I can square root both of these, right? So that's how I know it's difference of 2 squares. So I know the structure is going to be plus and minus, and now the first guy is the square root of m squared, so m and m on the first part, and then the square root of 49 is 7 and 7. Okay, we want to solve this. I cannot isolate the variable because x and x squared are both in it, so it's got to be zero product property. Zero product property says the thing has to be equal to 0. That's check, we got that. And the other side has to be a product. It is not. Product means multiplication. This is not multiplication. So that's why we need to factor. We're going to solve this thing, and we need to write it as a product. So this is a trinomial where a is 1, so I know the structure sets up like this. That's half the battle. Now I'm looking for numbers that multiply to negative 40, but add to negative 3. So I've got negative 1 and 40, 1 and negative 40. I'd like to show those sometimes. Don't forget about those. 2 and negative 20, negative 2 and 20. 3 doesn't work. 4 and 10. So negative 4 and 10 and 4 and negative 10. We're looking for them to add to negative 3. 5 and 8. So one of them's negative. And then also negative 8 and 5. Those are going to add to 3. It's going to be this one adds up to negative 3. So that's my answer. When a is 1, this just gets you straight to your answer. It's negative 8 plus 5. Now I can apply the zero product property. The zero product property says if I have a product, which I do, equaling 0, then the solutions are going to be when I make either factor or either part of the product equal to 0. Right? Because it makes sense. If I have 2 things times each other equaling 0, it's going to be 0 if either one is 0, because 0 times anything is 0. So I set up little mini equations that force each part to be equal to 0, and then I solve those. So the x that makes this one 0 is 8, and the x that makes this one 0 is negative 5. So let's take a second here and just make sure, so you can see how this works. If I plug an 8 in up here, right, for x, I get 8 minus 8 times 8 plus 5. So 8 minus 8 is 0. I don't even care what this comes out to be, the 8 plus 5, because 0 times whatever is going to equal 0, which is what we want. That's why it's a solution. Another solution is negative 5. If I plug in a negative 5 in this factor, I get that. In this factor, I get that. I get negative 5 plus 5 is 0. I don't care what I get over here, because 0 times that is going to be 0 anyway. Right? So that's how this zero product property is working. That's what's at the heart of it. When you multiply by 0, it makes everything equal to 0. So that's how we do that. And that was our station number 3.